Good morning, guys. Here I am again in my little office in my house, making you another video. Yesterday we talked about, what did we talk about? We talked a little bit about circles, and we figured out how to do the area of a circle and the area of a sector of a circle. Today we're going to switch gears a little bit, and we're going to talk about trigonometric functions. That sounds more intimidating than it is. Trigonometric functions are something that you've already heard, you've already been introduced to, or you should have, and that is sine, cosine, and tangent. You may be familiar with SOHCAHTOA. I'm not sure how I feel about that one. The first time that I heard SOHCAHTOA, it came with, at the time, was kind of a normal story, but looking back was a pretty racist story about an Indian chief and blah blah blah. And I wasn't a big fan, or I'm not a big fan of that. But it's a catchy, easy thing to remember. SOHCAHTOA. It's sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Another way that I heard this done is some old hippie called a high tripping on acid, which isn't something we're going to talk about in this class, but it's an easy way to remember it. So I've switched it up to something much better that I will say every now and then. Some old hippie cured a headache taking old aspirin. So, if you want to remember that, I don't know, whatever's easier for you, that was some old hippie cured a headache taking old aspirin. If you want to remember that, you can remember that. If you want to remember SOHCAHTOA, ignore the racist story that I learned as a kid, and just remember SOHCAHTOA. It's kind of a, I don't know, it's a catchy thing. Or if that doesn't work for you, you can make up your own. But that's the whole point, is there's ways to remember this. So let me switch to this guy and draw a triangle. Oh, about there and about there. Okay, so here we have a right triangle, or near enough to one. There's my 90-degree angle, which makes it a right triangle. Okay. Now, if we take sine and that equals opposite over hypotenuse. That's a y. Hypotenuse. Opposite over hypotenuse, that's sine. It depends where you're at. So if your theta is here, and you want opposite over hypotenuse, it would be this one over the hypotenuse. Remember, the hypotenuse is always the one opposite of the right angle. You can think of it as the longer one, but there's some times where it's kind of hard to tell which one's longer. Just remember, it's the one opposite of the right angle. That's the hypotenuse. So if I want the sine of theta here, then I would take, say this was, I don't know, I'll make up some numbers. This was 5 5 and this was 10. Good, because I know that sign. So the sine of theta right there. So we're trying to figure out what the angle is. What is theta, right? What's that angle? We don't know. So if we take opposite 5 divided by 10, so 5/10 equal to 1/2 is equal to 0.5. And I just happen to know off the top of my head that the sine of 30 is 0.5. So this would be a 30-degree angle. On your fancy calculators, if you hit the second button and then sine, and you type in 0.5 and hit enter, it'll tell you 30. If you have your triangle. Ooh, boo, 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 boo. These straight line tools are wondrous. All right, we have our triangle. We have our 90-degree angle. And we want to figure out, like, say this is a tree, right? And we have a dude standing there. We're looking at ground level here. So this is the base of the tree and this is the top. So we'll call this X. This is the distance to the tree from where you're viewing it to the tree. This is theta. And then this would be H for the height of the tree. So you could figure out what is the tangent of 30 degrees. All right, so we'll say 0.58. 0.58. Go back to my board. So we have 0.58 equals H over 40. We can say 0.58 over 1 equals H over 40. We can use my butterfly method. We're trying to find H, so we go next door. We say 0.58, then we multiply times 40, and we divide that way. Well, that's just 1. So 0.58 times 40. This time we can use the basic calculator. It's obviously more effective if you have a nice calculator and you can just use, hit tan 30 and then multiply it by 40 because that'll give you more decimals and be more accurate, times 40. So that tree is approximately 23.2 feet tall. Right? That's how we figured that out. Now what they have you doing in, let me erase this. What they have you doing in the worksheet is slightly different from that, but not that different. So it gives you your right triangle, but it has little Johnny standing here, wee, wee, and he has some kind of tool that he's looking through at eye level. And this is your tree, and this is, but Johnny has a certain amount of height to him, right? So when he's going, making that 90-degree angle, that's not going to give you the height of the entire tree. So they also give you, dun, 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 I need. Sorry guys, I am kind of out of it today. I'm gonna undo that. Pretend this is all just a straight line and Mr. Jeremy's not an idiot. Just pretend. Make believe. Make believe that this is done perfectly. It gives us this, and it looks so much more intimidating. It's like, what the heck? So we have Mr. Jeremy being an idiot again. We have H1, and we have H2, and X, and then it does this thing where it says theta 1, theta 2, and then it gives some numbers. Let's say 75 feet, X equals 75, and H1, hi, wow, H1 equals 4 feet, and theta 2 equals 50 degrees. I don't want you to figure out the total height of the tree. Well, that's just doing what we just did twice. That's all that is. Because you add H1 and H2 and you get the total height of the tree. So we have X is 75. So let's go ahead and we'll replace this X with 75. And H1, we'll replace that 4. Theta 2, we'll replace that with 50 degrees. So I have opposite over adjacent again. We're doing a bunch of tangent here. Excuse me. So I wish my calculator was working, but it's not. So we'll go back to here and we'll say, what is the tangent of 50 degrees? Back to you. Tangent of 50 equals 1.19. 1.19. All right. So then we want 1.19 equals, and we'll say H2 divided by 75. Again, we can use our butterfly method here. H2, go next door. You're going to multiply 1.19 by 75. Oh, gosh dang it, I was trying to use my calculator with the dead batteries. 1.19 times 75. And then multiply that way, we would divide that way. Dividing by 1 does nothing. So we know that this is approximately, and I say approximately because I used a rounded value instead of just the tangent, 89.25 feet. The whole point was to find the height of the tree. So 89.25 plus 4 would be 89 plus, wow, screw it, 89 plus 4 is 93.25. So the height of the tree is 93.25 feet tall. Approximately. Because again, I rounded it. So it's not that bad. despite the fact that I made it seem so much worse, because I'm a little bit out of it today. But there you go.